Hello, everybody. Welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving to over 100,000 computing professionals and students who are ACM's members. I'm Eric Meyer. I'm currently the CEO of Applied Duality, Inc., which I founded in 2013. In the past, I headed the cloud programmability team at Microsoft, where I worked on C#, Visual Basic, Link, Volta, and the Reactive extensions framework Ajax. And that's where I also met Jafar. My research has included functional programming, compilers, language design, and a lot of other things. I'm also a professor at the Delft University of Technology, and a member of ACM's Q magazine's editorial board, for which we always like to get articles. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM learning resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. For example, ACM provides timely computing information published by ACM, including communications of the ACM and Q magazines. That's the magazines that I work on. Highly recommended. Access to the ACM Digital Library, the world's most comprehensive database of computer literature. I couldn't live without it. International conferences that draw leading experts on a broad spectrum of computing topics, support for education and research, including curriculum development, teacher training, the ACM Turing Awards, and Infosys Foundation Awards, and ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Every computer science, every serious computer scientist should be a member of the ACM. Before we get started, I'd like to mention a few housekeeping items shown in the slide in front of you. In the top right corner, there's a button that will allow you to enlarge the slides. You can also enlarge the slides at any time by dragging the corner of the slide window. The slides will move automatically throughout the event as the speaker progresses through the talk. During the presentation, you can minimize the slide area. You can also use the widgets, including Facebook, Twitter, where you can get a copy of the slides. If you're experiencing problems, refresh your console by pressing F5. If you're on a mobile device, you can open and close the presentation. To control the volume, just click on the speaker buttons to increase or decrease the volume. And at the end of the presentation, you will see a survey. This recording will also be recorded, and you can check at learning.acm.org for updates. Good. I want to introduce today's speaker, Jafar Husain. Jafar works at Netflix at the Cross UI team. He is the technical lead there. He specializes in application servers and user interfaces using reactive programming. He's also a member of TC39, the standards body that is responsible for JavaScript. So if you have any feature requests for JavaScript, book Jafar. Jafar is one of the best speakers I know. He delivers a lot of talks about reactive programming at various conferences like HTML Dev, QCon, CodeMash, YAO. He has given many Channel 9 interviews on the topic that you can also look online. And he has also authored fantastic interactive training about reactive programming that's available on GitHub. Jafar, let's listen to your presentation. I'm really looking forward to it.
Well, thanks very much, Eric. So thanks everybody for joining today. Really, what I'm going to talk to you guys about today is how Netflix solved really big asynchronous problems just by thinking differently about events. Now, I'm going to take us back in time about three years, and I just joined Netflix. And what we had actually a pretty complicated asynchronous application. Now, like most JavaScript applications, Netflix app is very asynchronous. We have lots of things going on in the application at any given time that are asynchronous process. So for example, we're waiting for app to start up asynchronously. We're waiting for the player, which is a native component, to get initialized asynchronously. We're waiting on data access. Everybody does remote cloud data access, and that's asynchronous. We are using nice animations to blend transitions between screens and coordinating that as an asynchronous process. And finally, often binding our model to our view and reflecting changes in our view is an asynchronous process as well. And I'm sure your apps have some very similar things here. So wherever you have asynchronous programming, you have asynchronous problems. And here are just some of the types of problems that you can experience when you're doing asynchronous programming. So the first is memory leaks. Has anybody ever attached an event handler to an event and then forgotten to detach it? I'm sure that's happened. Race conditions. Sometimes it's so hard to coordinate concurrency that we can sort of, try and do two things at once. And when we're testing, process A always completes before process B, but then in the wild, those things can get flipped around because of the unpredictability, and we can end up with a race condition. Callback hell is a term that I think a lot of JavaScript programmers are actually familiar with, and that's this idea of having to coordinate everything that's going on in your program with all these different callbacks. And what you're really finding yourself having to do is split up your algorithm into arbitrary chunks just to make sure they get resumed after an async call, and that can be really difficult. Complex state machines. When you have a lot of asynchronous things going on, you've got to track whether they're complete or not. And often that involves introducing state to track that. And introducing state to track whether asynchronous actions are done or not can be a lot of extra complexity. And and eventually this complexity can kind of choke your application. And finally, and this is a big one, error handling. So if you use try, catch in your language, you know that when you go to async programming, try, catch are pretty much useless. We're used to these nice affordances of having our language propagate errors up into a nice place where we can catch it, but as soon as we move to async programming, we find that that disappears. So for an example of all these problems, or at least some of them, let's take a look at this slide right here. Now, in this particular slide, we have a piece of code, and this is very similar to the code we used to have in the Netflix application that attempts to play a movie when a user selects it. And so we accept the movie ID, we accept a cancel button, which we will listen to just in case they want to cancel playback, and we accept a callback. And the idea is we're going to go and try and authorize the playing of this movie and call back when it's successful. But we can't just immediately start playing a movie because our player may not be initialized yet, and we have to asynchronously wait for the player to get initialized. Now what we're really doing here is we're saying, I've got to first wait for a movie ticket, basically the authorization process from the Netflix server, and I also have to wait for the player to come up. And I basically need to track that both of these things are done before I can play something. Now, when we're using callbacks to track these things, you'll find that in order to track that these things are done, I have to introduce variables. So notice here, these state variables that we've added to the function. These state variables are going to help us keep track of when both of these actions are done. So basically, every single time either a movie ticket or the player gets initialized, I'm going to check to see, well, if the player is initialized, is the movie ticket available? If the movie ticket's available, is the player initialized? And if both those cases are true, we can see that I call back. Now, that's a lot of state, and as I talked about in the previous slide, if you have to keep introducing variables for all these async processes, the danger is those variables are going to get into the wrong state and you're going to have bugs. So state bugs are one of the really painful things about doing async programming. But another, and even I think more painful thing that most developers experience all the time is error handling. Notice here that I don't have the benefit of try catch. So I have to introduce this play error variable that keeps track of the fact that I have an error, and then I have to make sure that if either the authorized movie fails or the player fails to initialize, I track that error and then I report it back. Now, so we've got yet more state that we've added now to this function. Now, one thing I want you to notice is I've actually left a bug in here, because if you notice, I take that cancel button and I register an event listener, and when they click that event listener, I essentially cause an error to happen and we cancel. Now, I forget in this particular slide to remove that event listener. So what happens is every single time people play, what we're going to do is we're going to keep attaching these event listeners to this handler, and they're never, this event handler, and they're never going to get read. Eventually we'll. So how did things get so bad? Why is async programming so hard? Back to 1994, that's when all these problems actually started. That's when asynchronous programming got so hard, because we actually made a little bit of a mistake. So I want you guys to take a look at this book. And I'm sure there's some of you out there who have this book or have at least read this book. It's the Design Patterns book, a really important seminal book from 20 years ago, written by the Gang of Four, the so-called Gang of Four. And what the Design Patterns folks did is they attempted to take a look at the common patterns that were used and explain how they were all related. And so in the book, you can see here there's all these different patterns, and they're outlined in this diagram. And what they've done is they've drawn lines between these patterns, and they've talked about which of these patterns are related. Now, today in this presentation, we're only going to focus on two of these patterns. We're going to focus on the iterator pattern and the observer pattern. Now, the iterator pattern and the observer pattern, I want you to take a close look. Notice that the Gang of Four did not draw a line between these two patterns. They didn't think that these two patterns were related. But I'm here today to tell you that I think these two patterns are related. And they're actually related at a very fundamental level. And understanding how they are related is the key to understanding how asynchronous programming can become a lot easier. So first of all, a lot of JavaScript programmers aren't familiar with the iterator pattern. It's more common in places like Java and C#. But the good news is iterators are actually coming in the next version of JavaScript. So the way an iterator works is that you have a data source and you have a data producer and a data consumer. And in this case, the getNumbers function is the data producer. And I'm going to consume the data inside of this getNumbers function via an iterator. So how an iterator works is it basically allows a data consumer to pull values one by one from a data producer. So notice I get an iterator from getNumbers, and then I call the next function. And what that does is it returns a little tuple that gives me the value of 1 and a Boolean indicating whether or not there's more data to come. So it turns out that we're not done. So I'm going to go ahead and call next again, and I'm going to get another number. And we're still not done, so I'm going to call next one more time. We're going to add another number. Well, we're still not done. I'll call next again, and sure enough, this time we just get the message that's done true. So what that allows the consumer to do is just progressively pull information from a data producer. Well, if you think about it, the iterator pattern is not so different than the observer pattern. The observer pattern, which most JavaScript developers are familiar with, in the form of things like PubSub, DOM events, or node streams. It's this notion of handing a data producer a callback so that they can send you data. Now, in the iterator case, the data consumer is pulling data out of a producer and getting one item at a time progressively. Now, if you think about it, the observer pattern is actually very similar. We're handing an observer a callback, and it's pushing data into us one by one item by one over time. And so what's really common about the iterator and the observer pattern is they're both about a data producer and a data consumer. See that with the mouse, right? We move the mouse and we see that data getting pushed to us from the data producer. So what's common about these two patterns is they're both ways for a data producer to progressively send information to a consumer. There's really no difference. The only difference is in the observer pattern, the producer iterates you. Right? In the observer pattern, the producer is pushing values at you, and in the iterator pattern, we're pulling values out. Now, we didn't notice this correspondence before, but it's really important. So the question I want you guys to ask yourselves is, what's the difference between an array and an event? They're both sort of collections of data. That's really what it is. They're both collections. So I want to talk to you now about how we can think very, very differently about events. But before we do that, we're going to break for a brief, very brief, JavaScript 6 tutorial. Now, this technology that I'm going to talk to you about today has nothing to do with JavaScript 6. The only reason I'm going to tell you about it is, well, there's two reasons, actually. The first is, as Eric mentioned, I'm actually a member of TC39, and so I work on the JavaScript committee, and we want people to get excited about JavaScript 6, because it's very exciting stuff. And the second reason is that JavaScript 6 allows you to write much less code to do much more, and therefore allows me to fit much more code on slides. So if you'll bear with me for a moment for a very brief JavaScript 6 tutorial. Now, in JavaScript 5, you can create a function inline just like this. However, coming next in JavaScript 6, you'll be able to get rid of a lot of this boilerplate code, and you'll find that this code can simply be replaced with a nice little arrow. Now, if I could hear your applause, I would pause for it at this point, because I think this is a very big deal for JavaScript developers. So that is the end of the JavaScript 6 tutorial. Thank you very much for bearing with me. And now that you know that arrow means function in JavaScript 6, the slides coming up will use the short arrow as a shorthand syntax for functions. So I want you guys to bear with me here. I'm about to show you a bunch of functions. And in fact, the majority of Netflix's async functions, or async code rather, is written with just a few flexible functions. And if you'll bear with me, you'll be surprised to find that these functions seem to have nothing whatsoever to do with asynchronous programming. So let's take a look at for each. Now, anybody who's used JavaScript before probably has experience with the arrays for each method. Now, notice that this arrow syntax we have here is just shorthand for a function. You pass a for each, invokes it for every. Run this code right now, we'll see that we actually get 1, 2, 3 out. So some of you may be less familiar, however, with the map function. Now, the map function is also available on the JavaScript array. And the way map works is we can take a collection and we can apply a function to every item in that collection, and we create a new collection of the results. And so in this code example you see right here, I'm going to take this function and I'm going to apply it to each item in the collection. And so we're just going to add 1 to each item in the collection. But instead of changing the collection, we're going to create a new collection with the results inside of it. And so therefore, if I run this code, I'm going to get 2, 3, 4. So hopefully that's clear to everybody. I want to stress again, we haven't changed the source collection. We've just created a new one. Now, the filter function, again, some of you may be familiar with, it's almost the same as map. We still create an entirely new collection from an old collection. But this time, instead of a function translating the value, we pass in a test function. And each value in the source collection has the test function applied to it. And if that value passes the test, it makes it into the new collection. So as you can see in this example, we're filtering a collection for all of the elements larger than 1. Now, once again, we're not changing the source collection, we're creating a new one. And so we'll see that what happens is when we run this, we get a new collection with 2 and 3 in it. And there's one more function I'm going to teach you guys for now, and that's concat_all. Now, concat_all is actually not a JavaScript function, but it's very easy. We could easily add it to the array object if we wanted to. But just bear with me. Let's imagine we can define it. The way concat_all works is it takes a multi-dimensional collection and reduces the dimensionality by 1. So in this case, we've got a 2-dimensional collection of numbers. If I apply concat_all to this, I'm going to get a 1-dimensional collection of numbers. So you'll see I end up with 1, 2, 3, 4. Now I want you guys to notice something. The empty array just disappears. That's going to be important later. If you flatten a 2-dimensional collection and one of those collections is empty, one of those inner collections is empty, that collection just disappears. So let's do a quick review of map, filter, and concat_all. I'm just going to pause while you guys take a quick look at that. Now, I'm going to jump right in to the Netflix UI. Now, hopefully there's lots of Netflix users out there. And if you use the Netflix UI, you know that our model is at least seems quite simple. Well, whenever you log into Netflix, you get a list of genres. And within that list of genres, you have a list of titles. So it's one way of thinking about it is it's kind of like a 2-dimensional collection. So I want us to imagine we're going to use, let's see if we can use map, filter, and concat_all to get a list of your favorite Netflix titles. So it can't be that hard, right? Let's take a look. So here's a slide that uses map, filter, and concat_all to get a list of the top-rated movies for you out of your particular video list collection. So we're going to create a function called getTopRatedFilms, and we accept a user. We're going to map over all of the user's video lists. Now, each one of those video lists contains a. Before we return that videos collection, we're going to filter the videos collection for only those videos that have a rating of 5. Now, because we're returning a collection for an inner collection for each video list collection, we end up with a 2-dimensional collection. So then we apply concat_all to that 2-dimensional collection to flatten it down into a nice flat list of your videos that have a rating of 5. And so we can call getTopRatedFilms on a user now, and we'll get out a list of all their top-rated films, and then we can consume the collection and do something with it using for each. So notice there we're just consuming that collection using for each right at the bottom. So what would you say if I told you that you could create a drag event, mouse drag event, with nearly the same code? So let's take another quick look at the top-rated movies collection function, and I want you to look very closely because if you blink, you're going to miss it. I'm going to switch now an example of how to write the functions that I've already taught you, plus one extra one. Look quick. I'm going to make the switch now, and there we go. Notice here I'm creating a mouse drags collection, and the code has nearly exactly the same structure as the code that we wrote to grab the top-rated movies out of an array of arrays. So what's going on here? Well, we were writing a getElement drags function, which accepts a regular DOM element. And we're going to imagine that instead of add event listener, remove event listener pairs, every event on a DOM element is actually a first-class collection, just like arrays. Now, if we can make events into first-class collections, we can add methods to them like map and takeUntil and concat_all. So notice we have this collection of mouse downs, and basically you can think of it as a collection from all the mouse downs from now until eternity. And I'm going to map over all of those mouse downs, and for every single one of them, I'm going to return the collection of mouse moves from now until eternity. Now, before I return that collection, in the previous slide, we've filtered the inner collection using the filter method. In this particular example, we are going, I think actually that filter should be crossed out there. So for those who look at it, seeing it, what looks to appear invalid syntax, there should be a strike through that filter. So what we're now doing is replacing the filter method with a takeUntil method. So in the previous slide, we used filter to reduce the items in the collection. In this slide, we're using a new method, which I'll explain to you, called takeUntil, which reduces the number of items in the collection that we produce there from mouse moves. So what takeUntil does is it takes this collection of mouse moves from now until eternity, and it ends the collection the next time a mouse up happens. Now, because for every single mouse down, we're returning this collection of mouse moves until the next mouse up, we end up with a two-dimensional collection, just like in the previous slide. So we're going to take that two-dimensional collection, and we are going to flatten it down into a nice flat collection of all of the mouse moves that happen between a mouse down and a mouse up. And then we're going to use for each to consume those points, those drag points in the collection, and we're just going to change an image position in result, and now we've got a mouse drag. So how does this work? How can code like this possibly work? Well, it all has to do with a new type that our illustrious moderator Eric Meyer actually discovered sometime in the last 5 years. Now, the observable type, the way to think about observable is collection plus sign. So the observable is just basically taking the ideas of the observer pattern and codifying them, but adding things that were missing. And we'll talk about what was missing in a moment. So how can you get your hands on this library? How can you use this observable type? Well, the observable type is basically like an event, but it has all of the methods that are on the array method, or most of the methods that are on array. And you can download this in an open source library called Reactive Extensions. Reactive Extensions is available for a variety of platforms. I think it's now even more platforms that are on this slide here. And it's basically the observable type with most of the array functions implemented for the observable type, so that you can use the array functions over events and asynchronous data streams. It's open source, as I mentioned, and it's been ported to all these platforms. So what can you model with an observable? Well, you can model pretty much everything that's interesting for user interfaces. User interfaces are basically events, animation, and asynchronous I/O. And observables are capable of modeling all these things. Well, that's really powerful because Observable allows us to blend these things together and sequence them very, very easily, compose them together. And so that's really, really important, and that's why Netflix is so keen on using RX to build our user interfaces. So how do we turn a regular DOM event into an observable? Now, in the previous slide, it won't work out of the box because I'm using these supposed first-class event objects that don't really exist on the DOM. But we can take any DOM event and get a first-class event observable, essentially, using this helpful from event method. So here I am passing in a DOM event and the name of an event, and now I've got a first-class mouse moves object with all those helpful methods like map and filter sitting on it right there ready for me to use. So how do you subscribe to an observable? How do you get the data out just like you would for an event? Well, let's take a look at how it works for DOM events. So the DOM event, I create a handler, and then I call this add event listener method. And then when I want to unsubscribe, I call this remove event listener method, and I pass in a handler. Now, observable works almost the same way. In the previous slide, you saw the use of for each. We think, in terms of events, we think of for each as just a way of traversing a collection, much the way for each traverses a collection in an array. The difference is that the for each method, unlike in an array where it executes synchronously and fully completes, the for each method executes over time with the observable as data arrives in that collection over time. So for each is asynchronous. Now, notice that for each has a new trick up its sleeve with observable. When I call for each, a value gets returned and it's a subscription object. And that's essentially something that we can use to unsubscribe by calling dispose on that subscription object. Those JavaScript developers who are familiar with things like set interval and clear interval will be somewhat familiar with this concept of calling set interval or set timeout and getting out at some sort of handle they can use to cancel that, to basically stop receiving information from the data producer later on. And that's really what this is about. When we subscribe, we give the data producer a way of pushing us information, and when we unsubscribe, we signal to the data producer that we don't want any more information. So if you look at this slide and the previous slide, it doesn't seem like there's that much difference between adding an event, adding a listener to an event, or adding a listener or traversing the data in an observable collection. But that's just the basics. The real advantage of observable is because it's a first-class object, we can add all these map filter functions that I showed you earlier. Now, I also mentioned that Eric, when he created this observable type, he added some things to the observer pattern that were not present. And this really goes back to that talk we had about the design patterns and where those folks made a mistake. The iterator pattern and the observer pattern are both fundamentally about the same thing, but the odd thing is the iterator pattern has two things that the gang of four did not give to the observer pattern, two semantics. The first semantic is, well, we know both of these can send data. The producer can send data to the data consumer. In the case of the observer pattern, we call a callback. And in the case of the iterator pattern, we call next on the iterator. But notice the iterator, back when we were using it, could tell that it was a way that the data producer could tell the data consumer that there was no more data. Remember that done flag on the tuple that we got? There was a way for the producer to tell the consumer there's no more data coming. And the third semantic, which is sort of ambient and there for all synchronous programs, is that the data producer can tell the data consumer that an error occurred. With iterators, when I, as the data consumer, call next on that iterator, the data producer can throw and let me know that an error occurred. But throwing doesn't always work when you're asynchronous for signaling that errors occurred. So what we did with observable is that we added two extra callbacks to for each. So for each can optionally accept these two extra callbacks. So the first callback there is the one that receives the data, but the next callback is a callback invoked by the data producer to tell the data consumer that an error occurred asynchronously. And that final callback is the way for the data producer to tell the data consumer that there is no more data coming. And then as you can see at the bottom, if the data consumer decides, even if there may be more data there, I'm not interested in getting it, they can always dispose of the subscription. This is very important because we're essentially righting a wrong that's 20 years old by making the iterator pattern and the observer pattern semantically equivalent. You can have all the same semantics in both. Now, that allows us to do that. What that means is that anything we can do to the iterator pattern, we can do to events and the observer pattern. And that means that we can do things like SQL, which we know how to do over iterators, or sets, which are iterators, and we can take those same types of operations and apply them to observables and events for that matter. So let's take a look at what I'm going to do is just to make it easier to understand this collection over time, this observable that enables us to do all these things. I'm going to invent a fake syntax. So I want to warn you, this syntax, this literal syntax for observable is not in JavaScript 6. I'm just making it up for the purpose of these slides right here. So, bear that in mind. Now, as you can see here, what we have is a collection arriving over time. So all of the same methods, as I mentioned earlier, that are available for array are now also available for observable. So if we call for each on this observable, this collection over time, we still get the same result. We log each of these things to the console. However, what happens is we log them slowly as these elements arrive over time. So notice it's no longer synchronous. It happens asynchronously as the elements arrive. And the same exact thing goes for map. So map is now defined over observable. And if we run arrive, they're run through the function and translated and then written to the console. So I'm sure you guys can guess that filter works exactly the same way. The first element arrives, but it doesn't pass the test, so it doesn't make it in. Finally, 2 comes along, passes the test, 3 comes along, passes the test, and is returned. And finally, remember concatal. Concat all was that function that takes a two-dimensional collection and reduces it to a one-dimensional collection. Well, ask yourself this. What would it mean to concat all an observable of observables? An observable of observables is really like an asynchronous sequence of values where each one of those individual values are also asynchronous sequences of values. Now, this might seem complicated at first, but the reality is many asynchronous problems that you might face on the UI are actually best modeled as observables of observables. So concat all, when applied to an observable of observables, allows us to work out things like race conditions. Now, if you subscribe to two different events, those, doesn't matter in which order you subscribe to the events, those values are going to fly out at you as soon as they arrive, independent of the order of in which you subscribe to the individual events. It doesn't matter. Both of their data may arrive at the same time, concurrently. Concat all allows us to solve this problem. What concat all does is it takes an observable of observables and it enforces order. So you can see now we have a collection of collections, and each one of those inner collections is arriving over time. And so once we for each over the collection that comes out of concat all, what happens is we get the first collection in and we start listening to it. And we take its data and return it immediately. After that completes, we get another collection in. We begin for eaching over that, and we immediately return its data to the flattened stream. Now, while we're waiting for that collection to return data, another inner collection comes along, and that's this empty collection right here. Now, we for each over this, there's nothing, and then we don't return anything. Notice that when we're flattening this two-dimensional collection, this empty collection just disappears. But right before that empty collection finishes, yet another collection comes along. And this collection contains only 4. Now, the key thing is, instead of returning this value to the flattened stream, we're going to hold on to it, we're going to cache it, and wait until that second collection is actually finished. We're essentially enforcing that data in the elements come out in the order in which their collections arrive. So while, in the meantime, we're waiting for that second collection to finish. It finally does. It gives us 3. And now and only now do we take that value that we've cached up, the number 4, and return it. So finally, we end up with the collection 1, 2, 3, 4. So the interesting thing about observable is that once you have a collection over time, there are more than one way to flatten that two-dimensional collection into a one-dimensional collection. And this is really, in many ways, the heart of concurrency. This is what makes concurrency hard but also powerful. Well, if you have a collection of collections over time, then there's different ways of skinning a cat, so to speak. Now, an array of arrays, you only got one option. You flatten top to bottom, left to right. You can do odd things like going backwards, but that doesn't really make a lot of sense. Imagine if instead of, like in concat all, returning those elements based on the order in which the collection arrived, we return the elements as fast as they arrived, independent of which collection, independent of the order in which the collection that has them. So in other words, merge all behaves exactly like when you would subscribe to two different events. Doesn't matter which event you subscribe to first, whichever data comes from whichever event in whichever order is returned immediately. So in this case, we begin listening for our flattened collection. First, that inner collection comes along with 1, we immediately return it. Another collection comes along, immediately fires 2, we return that. And then while we're waiting for that collection to fire, another collection comes along. This one's empty, so we return nothing. Basically, that collection essentially disappears. And we're still waiting for that second collection to finish, and yet another collection comes along, gives us 4. We return that immediately because we're merging. And then finally, that last collection returns its last value and completes, and then we say the whole collection is now complete. So merge all is easy to understand. It's like a bunch of cars merging together into one lane on the highway. Now, concat all helps us resolve race conditions, and merge all is great for when we want the data to flow through as quickly as possible, and we don't care about the order. But one of the most common patterns that Netflix uses in our user interfaces is switch latest. Now, I want you guys to think about whether maybe, let's say, you've created a button on screen, and every single time somebody clicks that button, they go and get a stock quote. Now, if you make a request every single time that button is clicked, and then you take that program and you hand it to your QA engineer, what's the first thing that QA engineer is going to do? They're going to jam on that button as fast as they can, and what's going to end up happening is that you're going to saturate the number of WebSockets available and eventually actually run out of memory, depending on how tenacious our QA person is here. So what's very common in UI is that we want to respond to the latest thing that the user did, and we don't care so much about the thing that they did before. So the switch latest pattern encapsulates this idea by taking a collection of collections and basically just returning data from the latest collection that arrives. So we can see here we get that first collection with 1 in it. We start listening, and we return that to the flattened stream. And then while we're waiting, the first collection then finishes, and then immediately another collection comes in and returns its first element too. Now while we're waiting for that first collection to finish, another collection comes in. But because this is the switch latest pattern, we just stop listening. Remember when we take that subscription object that comes out of for each and we dispose of it? We stop listening to that second collection and immediately start listening to the new collection, which means we're never going to get that last item, number 3. And so once again, empty collections disappear. And out along comes a new collection. This one just returns 4. And so you can see switch latest loses data, but it always, always responds to the latest observable that comes along. Now, I promised you guys I would explain the take until function, because the take until function is really, really useful. So take until is very straightforward. With take until, we have a source collection, which is what we're listening to, and we have a stop collection. And we just keep taking data from the source collection until finally the stop collection fires a single value, and then we complete the overall collection. And at that point, we necessarily unsubscribe from both the source and stop collection and clean up after ourselves. So the interesting thing about take until and the new 2 semantics that have been added to the observable, we essentially added to the observer pattern, the ability to say we're done, no more data, and the ability to send an error, is that we can now fundamentally change the way that we approach event programming in UIs. For the last 20 years, we've been thinking that when we subscribe to an event, we have to then build some sort of state machine, and then when the time is right, we're going to unsubscribe from that event. But the ability to use take until to essentially complete collections when we don't want that data anymore, when we've decided that we don't want the data from that situation anymore. So for example, completing the mouse moves collection with when the mouse down collection fires, we don't have to now build state machines and manually unsubscribe from events. Instead, what we can do is we can create events declaratively that complete when we want them to stop, when we want them to complete. So we don't unsubscribe from events anymore. We complete them when another event fires. So let's take a look at the mouse drags example again, because now you know how these methods work and you can sort of see how this whole thing comes together. So instead of building a state machine, which I might do if I was building in mouse drags, which you might think, if you might think how you're going to do mouse drags, you might build a state machine by hooking up to events handlers and then trying to find the right state in which you unhooked your mouse move event handler. Here I'm actually creating a collection that ends. And the key thing about these collections that end, at least that inner collection there, mouse moves, take until, mouse puffs, is that if an observable ends, if it knows that there's no more data coming, well, it can unsubscribe you. And that's what happens with an observable. If you for each over an observable and that observable ends, the observable automatically frees your subscription. And so you need to remember and that's useful. For those of you who are familiar with things like document on load, right? Document on load is an event that fires only once. But if you don't come along and unhook your event handler, it's possible that you could end up holding on to resources captured on that closure long after you don't need them anymore. And so that's really stupid. Events today are kind of stupid. That even if they end, they don't bother to unhook your handler for you. That's one of the big differences around observables and creating event sequences that can end. Well, by allowing them to end, they can also do the work of unsubscribing for you. So now we've taken a look at an example where we combine events together. But I told you, observables can model animations, events, and asynchronous data requests. So let's take a look at a slightly more involved example that combines events and asynchronous data requests together. And it's something that I think a lot of web developers have had to do at one time or another. So I want you guys to think back to when you had to write an autocomplete box. Some of you, I'm sure, out there have had to write an autocomplete box at some time or another. And autocomplete boxes are complicated for 2 reasons. There's 2 things that really complicate them. The first is if I go into my Netflix search and I get an autocomplete and I type A, B, C, D, E, F, G, well, I as a developer probably don't want to send up 7 requests in response to that user input, right? What we'd like to do is we'd like to wait for a certain amount of time and then when the user stops typing, issue 1 request. So that's the first element of asynchrony that needs to get introduced into the autocomplete box. The next is that if I type A, and then after a certain amount of time I type B, well, what happens is first we get a request out for A, and then we get a request out for AB. But just because I make a request for AB after my request for A doesn't mean there's any guarantee that that request for AB will come back after the request for A. And so what can end up happening is we get our search results for AB back before the search results for A, and we end up showing stale data, old data, on top of the new data. And that's what we call a race condition, and it's really nasty to try and fix and work out. So let's take a look at how we would solve the autocomplete box problem with Observable. So what I've done here is I've created a sequence of all of the search result sets, an observable of all the search result sets. Now, a search result set is essentially an array of the results for a given search. So what I do is, well, I take the basic event, the key presses, I turn it into an observable, and then I throttle it. Using this throttle method, what I'm doing is I'm turning A, B, C, D, E, F, G into A, D, G. So basically, we just make the event less chatty. And I take each one of those key presses and I map over them, and I call the getJSON function and pass the current value in the text box. Now, getJSON is actually going to return an observable. It's going to return an observable that will fire with just the array of search results. So it's an observable that fires only one element, which is like an array. So it's like a collection of one. And that shouldn't bother us that it's a collection of one. There's nothing wrong with creating an array with one element in it. There's nothing wrong with creating an observable with one element in it. Now, that retry method I'm going to come back to. But I want you to notice the next method, take until key presses. So what happens is if I press A, and then after 250 milliseconds, we return the result of getJSON, which is now a two-dimensional collection, right? In the meantime, we've got this outstanding request for A, and somebody presses B. Well, take until will take that outstanding request for A that hasn't returned any data yet and complete it. It'll essentially turn it into an empty collection. Now, because for each one of these key presses we're returning a collection, albeit of just one value, that array, we still have a two-dimensional collection here. So we're going to use concat_all to flatten this down into one dimension. So for every key press I make, I'm going to create an observable, an inner observable in that two-dimensional observable. I'm going to create an inner observable that's going to eventually give me the search results, unless somebody presses another key, at which point that observable that will eventually give search results just becomes an empty collection. And then when we apply concat_all to an empty inner collection, what happens? It just disappears. So I used to think about events in terms of, this very mechanistic way where I would subscribe up to them and I'd cancel requests. I don't think about them that way, thanks to Eric and the work he's done. What I do is I think about creating collections of data that I want that complete when I want them to complete. So we've created now this two-dimensional stream of search result sets. And every single time somebody presses a key, if they don't press a key for another 250 milliseconds, or in the period during which the results for that key come back, well, the search results for that particular key press will end up in the stream. Now notice, and we're going to come back to the retry method now, notice that in for each, I can pass in this extra callback beyond the callback that just receives the data result set. I pass in this callback that receives an error. What's important to note is if an error happens anywhere in this process, and in this particular case, getJSON is the one that might potentially error, what Observable will do is it will propagate it all the way up to the for each method. So if getJSON, it invokes the error callback there, what happens is it behaves exactly like try-catch. If getJSON fails, we can essentially handle that error in one place inside of the for each. So this is essentially like a catch statement, an asynchronous catch statement. Now, the truth is, when you're working on the network, errors happen all the time, right? You could easily find yourself in a situation where you have intermittent network failures, and so in practice, we don't really just try a request and then if it doesn't work, give up. So that's what the retry method does. The retry method actually takes the getJSON observable and transforms it. And if the getJSON operation fails, all it does is it increments a counter and then calls for each on the getJSON observable again. And it just keeps trying until 3 failures, at which point it gives up and forwards along the error callback all the way up to the for each statement that you see here. And so using this, we now have asynchronous try-catch. We have all the affordances of asynchronous try-catch. Now I want you to notice something. This pattern in which we apply take until to an inner collection inside of a concat_all, well, it can be shortened to a switch latest. Now again, there should be a strike through the concat_all there that you see on line 8. So we're really replacing concat_all with switch latest. And there should be a strike through also with the take until key presses. So what you should be seeing there is just map, get JSON, retry 3, and then take that whole expression and apply a switch latest to it. So the take until and the concat all are crossed out. Because switch latest is just going to always stop listening to the previous JSON as soon as we create a new stream of the JSON results. And so this essentially encapsulates the same pattern as applying take until and concat all. So a switch latest pattern is ubiquitous in UI programming. We use it all the time at Netflix. So let me see here. There we go. This slide is actually the final short using the switch latest pattern. So I think we're running a little late on time. I had one more example to show you, but I think that's really the most important one. Why don't we skip to the end and take a look at, just do a quick summary. Nowadays, in Netflix, we use Observable everywhere. So all the things we talked about at the beginning of the presentation, we use app startup, player, data access, for all that stuff. Sorry, just bear with me a moment. Just want to make sure I'm still online here. Great, I am. And one thing I really want to call out is Rx is great. It's easy. This observable type is easy if you already know how to do array programming. But it can really help if you take a look at these interactive exercises that we've put together. So if you go to this particular address, you can see that what we do is we create these in code, right there in your JavaScript web page. You can fill out these interactive learning exercises, and we gradually teach you how to replace loops with map and filter statements, and then we eventually, just on arrays, and then we eventually introduce you to observable. Now, these exercises are what Netflix has used to train internally, 60, 70 developers to learn how to become experts at async programming using this technique. And I'll also do a quick call out and let you guys know that this technology is very likely going to arrive in JavaScript 7. So if everything goes well, you're going to be able to use observable natively in JavaScript 7. So if you start learning now, you'll be ready later on. And so here are a few resources you can take a look at. It's very important to just check out the LearnRx training exercises. You'll see my Twitter handle at the very bottom there. Please follow me and check that out. You'll find more information about Rx, and you can ask me questions as well. Now, I'll pause here for any questions.
All right. Thank you so much, Jafar, for your presentation, and our apologies for some of the technical difficulties. Let's go to some questions, Jafar. There's one question here, is how does this compare to promises?
Great question. So I think a lot of developers out there are familiar with promises, and I want to be clear. Most of what you can do with promises, you can do with observables. Well, actually, the truth is anything you can do with a promise, you can do with observable, and you can do more with observables. Now, am I telling you never to use promises? Not necessarily. Promises are coming in the next version of JavaScript, and I think promises are useful for certain cases. But I think many developers are overusing promises. They're using promises for scenarios where they're not really appropriate. And let me explain that for just a moment. So promises, one of the unfortunate things about a promise is that it is what we sometimes call a hot data source. Just like a mouse move event, for example, is a hot data source, meaning the work's being done, work is happening in the computer regardless of whether you're listening to it or not. So if you start listening to a mouse move 1 second later, then you might lose some data. A promise, you won't lose data because it caches its one and only value. However, when you create a promise, it's already doing the work. I want to go back a few slides and show you what that means. An observable doesn't necessarily do any work until you for each over it. And then and only then does it actually begin doing something. So if we take a look at this previous example here, so notice that in this particular example, the code above the fold in this slide actually does no work. All we've done is create a series of observables of observables of observables. And we don't trigger any work like get JSON or even subscribing up to the event until the for each statement. So observable is lazy and promises are eager. By the time you have a promise, it's already doing work. The problem with promises is they cannot be retried. Notice the retry operator we're using here. In order to retry a promise, you need to go back to the original method that created that promise and have it create another one. The other serious issue with, I think, with using promises to model asynchronous requests, which is one of the most common usages of promises, is that promises cannot be canceled. Promises are already in flight, and they give you no mechanism by which you can cancel them. And that's a serious issue. Remember the example in which you create that app in which you trigger an asynchronous request and you hand that off to your QA person? If you use promises to model that asynchronous request, that QA person is going to get that thing to run out of memory or at least slow down every single time. So promises are really about modeling the eventual value of an asynchronous request, whereas observables are more like modeling the actual process of getting that value. And so by returning that subscription object when you for each, they allow you to cancel it. And so I would say that the vast majority of cases in which people are using promises today are actually better served by using observables, even if those observables have only one value.
All right, so the next question, I think, which is interesting, is the difference. You talked about it, the difference between concat all and merge all. And one of the questions is, when you do concat all, shouldn't concat all take a timeout parameter? But I think, Jafar, you can explain how to solve that with composition.
Yes, so one thing you won't see observable doing is expecting timeouts or anything like that. And now how is that possible? Because so often it's so common to want to be able to do timeouts. Well, the way observable works is that we can apply a timeout anytime we want. So we can take an observable, either a sub-expression of observable or the whole observable expression, and we can use the timeout method. So, and just call timeout and then pass in a number right there. And so that essentially what that does is it then, when it calls for each on the inner observable, on the observable you've surrounded with the timeout operation. And if it doesn't come back within a certain period of time, it then calls on air. And so rather than every method having to accept a timeout, we can just add a timeout method to observable and composably add that behavior in.
Yes, and so I want to emphasize that that's kind of a very important thing, and that has to also to do with the fact that nothing happens until you subscribe, which means that you can compose these things to get the behavior that you want. Next question. There is take until, switch latest, etc. are non-deterministic. How does this compose when they are nested?
Sorry,
what happens, because take until and switch latest are non-deterministic. How does that compose when you get nested collections, nested streams?
Well, so switch latest is applied to a nested stream, so an observable of observables. And take until is applied to only a source observable and a stop observable. Now, all take until is going to do is it's essentially going to create a new collection of the elements in the source collection that just stops when you get an element from the stop collection. And that just turns into another collection that composes just fine. You can treat the result of take until like any other observable collection. And switch latest, when your comment about non-determinism is just, I want a little clarification there, but switch latest is essentially going to, once again, be composed. Like once you apply the switch latest behavior to a two-dimensional observable, you get a nice flat collection out that will complete depending on when all of the inner, both the outer and the current inner observable completes. But when you say non-deterministic, I'd appreciate maybe some clarification. Maybe you can add a Q&A.
Yeah. So that was not in the question, but I think the issue is that once you're dealing with asynchronous data streams, they are inherently non-deterministic, and when you're merging two asynchronous data streams, it just depends on the speed of each individual stream how they get merged. So that's the whole point of being asynchronous.
Yes, and it's absolutely, you're right. It's non-deterministic, and to some degree, these flattening patterns that we use here and these other methods are a way of trying to do our best with non-determinism. Right? We can say, look, I want to receive elements in the order of the collections, like in concat all, but you can't really control the fact that those concat all might take a very, very long time because the first collection takes a very, very long time, and all the other collections that arrive after it arrive almost immediately and would have completed almost immediately. So there's nothing, non-determinism is non-determinism, and Rx only helps you try and control that chaos, but there still is chaos there.
Yep. Just kind of, because the questions here are jumping around non-deterministically as they are added, so I was looking at one and then it disappeared. So here's a question. So can observable be used for events that are infinite, for streams that are infinite?
Yes, just like iterators, which iterator is basically a piece of code masquerading as a collection, because every single time you call next, you can just, for example, increment a counter and then return that value to give a collection of all natural numbers. Observables, too, can be infinite. In fact, it's very common that we will deal with infinite observables, and DOM events are a good example, because DOM events are based on the observer pattern, described 20 years ago. They don't have any notion of saying they're complete. And so in practice, a mouse move event could fire again at any time, right? A mouse move is an infinite collection because it could always fire again. And so when you turn DOM events into an observables, their onCompleted will never fire. That third callback that tells you when there's no more data coming, it will never fire. You have to sort of create it when you take two DOM events together and find them using sort of take until. So it's very common to deal with infinite collections. They're called DOM events.
All right, so then there's another question about concat all and merge all. Are there any other combinators for combining collections or flattening multiple two-dimensional collections into single-dimensional collections?
So the truth is there are a surprising number of what I call flattening operators that take two-dimensional collections and then merge them into one, or flatten them into one, essentially. However, it's important to note that Netflix does the vast majority of our code with concat all, merge all, and switch latest. And that includes not just UI code, I should have mentioned earlier, on the server, we treat our requests to the back end as observables, and then we take all those observables, combine them together, and create an observable finally of the response. And so all of our middle tier code, which we take data from the back end and munge it into code for data on the front end, is essentially treated as a one big observable composition. And so we tend to just use those three flattening patterns. There are many more, and there's some very interesting and esoteric ones, but you probably won't need to use them for most use cases.
All right, so I think we have reached the hour mark. That means that we are run out of time. Thank you so much, everybody, for listening in. The slides and the recording will be available in a few days at learning.acm.org/webinar. And I'm pretty sure that Jafar will also answer some of the remaining questions that we didn't get to offline. Thank you so much for your attention, and a big round of applause for Jafar. Thank you so much, Jafar.
Thanks very much, Eric. Appreciate your help. Bye-bye, guys.
Goodbye for now. Don't forget to fill in the quick survey if you get a chance. And thanks again for joining us. And have a great day. Bye-bye.